Thanks for being here, everybody. My name is Lauren. I'm here with my coworker, Thomas. We are both software engineers that work on cloud functions for Firebase. And today, we will be sharing with you how you can write production quality cloud functions code. To do that, we'll dive into 3 different topics. First, I'm going to talk about why you even want to use cloud functions in the first place. Next, I'll invite Thomas up, who will give us some tips, tricks, and also walk through some tools for how you can be writing cloud functions code. Then I'll be talking about how you can test the code that you just wrote using some tools we released recently. So first, why cloud functions in the first place? Today, you may have learned about some of the other Firebase products that allow you to write an app without a backend. So you learned about Firestore for storing your data, cloud storage for Firebase for storing pictures and videos. And these products allow you to write your app without servers. But sometimes you actually do need a server. For example, if you have secret code that you don't want visible to the client. This could be scoring logic if you're writing a game. You want to keep those things on the server. Secondly, if you are doing things that are very computationally intensive, you want them on the server so your clients can be performant and lightweight. And lastly, if you're writing multiple apps on multiple platforms, for example, iOS, Android, and web, you don't want to have to update all of them to add a functionality or a push a bug fix. By keeping code on the server, you can also avoid lengthy app review cycles, and you don't have to wait for users to update their apps. So you can host your own server, and in this kind of a model, you have to define an interface for communication between the server and the client. Typically, the client would be making HTTPS requests to the server to interact with it. You have to come up with an interface, an API, for these 2 things to work together. Cloud Functions for Firebase is a managed backend solution, and it offers a simpler programming model. You don't have to define an API based on requests unless you want to. If you want to, you can run in an event-driven manner. And what do I mean by that exactly? So Cloud Function is a snippet of code that runs on Google servers in response to events happening in your app. For example, a new user has just signed up, or a node in the database has changed values. One of these events happen, that triggers your function to run. Alternatively, you can still trigger these functions through HTTPS requests. And this is a great way to create webhooks. Webhooks are URLs that third parties can hit. So for example, Slack, Twilio, and Stripe are 3 of many, many external services you can use webhooks with to integrate into your app. So what are these events that can trigger functions? Firestore, our database solution. If something is written into the Firestore, you can trigger a function with that. As of today, you can listen to Crashlytics crash events with functions and trigger code to run. You can run code when there's a new user that signed up. You can listen to a database write in the real-time database. You can listen to an analytics event being fired, a new file uploaded in a storage bucket, or, of course, an HTTPS request. One thing that you can also do with HTTPS requests is you can connect it with hosting. So Firebase Hosting is another product we offer. It does hosting for your CSS and HTML files. Prior to functions, hosting could only host static websites that didn't change depending on who the user is. But with functions, you can actually have URLs that trigger an HTTPS function to run, which then gives content for hosting to render. This is great for rendering dynamic visual content, but also great for creating internal APIs that your app can hit to get information. So why do you want to use Cloud Functions to host your backend code? The first reason is it scales up and down. So if you're getting a lot of traffic to your app, you can trust that we will spin up enough servers and serve all that traffic for you. On the other hand, if you have downtime in your app, you're not paying for what you're not using. Secondly, because it runs on Google servers, it's already in a trusted environment. So with no additional code, you have authenticated access to Firebase and Google services. So you can do things like write into your project's database. You can access Google Cloud APIs, such as our machine learning APIs. Lastly, is fully managed by Google. Google operates at a planet scale, and we do the DevOps for you. So you and your team do not have to be burdened with that. So I just talked about what are all the great reasons for using Cloud Functions. Next, Thomas will dive into some concepts that will really help you write quality code.
Thank you, Lauren. So, Cloud Functions lets you write code that runs in Node.js, which means the tips I'm going to give you today will work in the future for other languages. But today, we're going to take a very deep dive in Node-specific tips to remember when writing your Cloud Functions. Now, the Firebase design process exposes us to a lot of customers. And oftentimes, those customers give us their code to look at to help them debug or redesign. And we notice a pattern as we work with customers. First, we noticed that customers very often had an intuition for how successful their code was going to be in production. Some devs would tinker a little bit, they'd deploy to production, and they'd leave it just still forever. Other devs could iterate in their product and know with confidence that when they deployed their code, it would work. And they weren't just being foolhardy. We noticed when we looked at these customers that they had high confidence because they exhibited some very common characteristics. We boiled it down to 3 traits of the most successful developers using Cloud Functions. First of all, these developers were able to express complex thoughts much more clearly. When they asked us to review their code, it was so much more easy to read, especially their asynchronous programming. You see, bugs love to hide in hard-to-read code, which means simple code will have fewer bugs. Second, these developers tended to lean more heavily on tools to develop their applications. And we're going to use 3 of those tools today. We're going to use linters, TypeScript, and IDEs. And finally, I'm going to hand it back to Lauren later to talk about some of the tools we've used to test code outside of production. Because we noticed that people who felt confident about their apps working in production had actually tested it elsewhere through unit testing, which we've already talked about in previous talks, through testing in staging apps, and through some of the tools that Lauren will show you later. So many developers struggle with asynchronous programming. We've boiled it down to what we call the 1, 2, 3 test. How many of you here might think if you're glossing over this code that it prints out 1, 2, 3? Well, it's understandable because these lines do come in order, 1, 2, 3. But this line right here means that printing out 2 isn't going to happen until the rest of the code executes. Now, when I call out the bug in isolation, that might be a little easy. But how many of you in 10 seconds can catch the incredibly dangerous bug in this code? Did you catch it? There's never a return statement here. Whenever an error happens in this code, it's going to keep on running, passing garbage data utilities and calling the developer's callback more often. Bugs love to hide in what we call the pyramid of doom. It's when your code keeps on nesting deeper and deeper as it progresses. This is a very, very common place to have mistakes in your code, which is why at Firebase we've been really pushing developers to adopt promises in their code. But there's just one problem. Your developers are so used to having the pyramid of doom that you've been reinventing it in promises. So here's that same code incorrectly written with promises. This is not how you write promises, folks. This still has that pyramid of doom. And it still has 2 more dangerous bugs. Did you catch these ones? Well, promises are return values. So you need to return them. That way the caller can actually interact with them. This is how we know to keep your Cloud Functions alive. If you don't return the promise, we'll probably shut down your machine early. Now, second, there is a time and a place for chain promises, or nested promises, but a simple sequence of events is not one of them. This catch block is attached only to task 3, which means any failure in task 1 and 2 is not going to be handled. So for everyone who's taking a picture, this is the correct way you write that code. Task 1, then task 2, then task 3, then all one line. No complex indentation, no pyramid of doom. This code is simpler, so it's much more likely to be correct. Now, there's two reasons that you should write your code like this. First, this is simpler. The amount of bugs in your code is directly proportional to the amount of code you've written, so write less code. Second, writing code with idioms helps you write fewer bugs as well. Your brain recognizes these patterns, which means you'll notice when the pattern is slightly off and you probably have a bug. You'll also be able to quickly glance through the code and extract the meaning out of this pattern. You start to recognize idioms over and over again. But this can go overboard. Here's code that I recognize. You shouldn't read it. I don't either. I just see this blob, and I remember that everyone's copied it from Stack Overflow. This is how you make a REST request if you're really trying to do it the hard way. So, consider actually using some tools to write your code. Here is that same code using a native library, request promise. This is much easier to read, much more likely to be correct. So let's continue our talk about tools and go back to that sample. This function is correct, but it would be great if we could do better. Because almost half of this code is boilerplate. Wouldn't it be great if we could focus on the things that mattered most? Well, today I want to give you a sneak peek of the future. Node version 8 adds two new keywords, await and async. Here's how it works. First, you declare a function as async. This means it's going to return a promise no matter what. It also lets you use the await keyword. You stick await before any command that returns a promise, and it tells Node, hey, I need a value here, not a promise. Go do something else for a while, and when that promise is resolved, continue this code with the value from that promise. So now we get to write lines like this that look so much more natural. Result equals await task 1, not task1.then result 1. So now our code looks almost exactly like our synchronous code. You don't have to keep on asking yourself about that 1, 2, 3 test. There's almost no boilerplate at all. And await turns rejected promises into real exceptions, which means you can use try, catch, and finally like you have for the last 10, 15, 20 years. There's almost no boilerplate. And here's another example. This code reads fairly simply. We're looping on an operation until it's done and printing out when we finished waiting. If you wrote this with raw promises, it would be much more complex. That while loop would be recursive. Try finally is actually pretty subtle with raw promises. We fixed a bug recently in our own SDKs because we implemented finally wrong. So why am I telling you about things that aren't available yet? Why are we in this tools section of this talk? Because today I want to talk to you a little bit about TypeScript. Now those of you who know me know that I'm a huge fan of TypeScript. It's a language written by Microsoft that extends JavaScript with type information, which helps you write better apps. First of all, because we have type information, your IDE can give you great code complete. And when you screw up, you actually get compiler errors. No more deploying and finding something is not a function. Yeah. A few of you have done that. Also, because we have type information, our linters are so much better. If you've ever forgotten to return a promise, imagine having a compiler automatically check that for you. And finally, TypeScript gives you features of Node.js that aren't available yet. So, I'm going to do today's demo in TypeScript. And we're going to see some of these tools in practice with an app that I like to call Alone Together. This demonstrates my favorite mathematical paradox called the friendship paradox. It says that most people are less popular than their friends. That doesn't make a lot of sense, but you can see an example here. We have a social graph with 3 people. One person knows 2. The average person has 1.3 friends, and 2/3 are below average. So I like this example because for people who grew up as loners like me, it lets me know that I'm not alone in being a loner. So to do this, we're going to use a Twitter API. We're going to find out how many people follow you, find out who you follow and how many people follow them, and do some stats. So it's a bit of complex code, so let's go through the architecture first. We'll start with the username and fetch the user's profile. Another request can give us the list of IDs of the people we follow. Now there might be hundreds and thousands of them, and we want to turn that into the friend's follower count. Well, we can't make thousands of API requests at once, we're going to get rate limited. So Twitter's given us a batch API, but that has a size limit as well. So we need to take our big array and break it into an array of batches. So to do that, before we call getUserLookup, we will call chunk. This will break up our array into subarrays of a maximum size. From there, we can do this lookup in parallel and use promise.all to wait for all the batches to complete. Now the opposite of chunk is flat map. It will take our array of arrays and give us one array of results. And now that we have our profile and the follower count of our friends, we can calculate some fun and existential statistics. So let's go ahead and see this in action. So when we write TypeScript, one of the first things you'll notice is that imports are a little bit different. It's because the require statement is very node specific. Before JavaScript invented modules, now JavaScript has, and TypeScript gives us access to the latest features. So we use things like import. This is the syntax that's equivalent to the require statement you're used to, but there are some more advanced syntaxes you can look up later. Next, we will initialize the admin SDK. The Firebase functions runtime automatically gives you the information you need to do that. Now, stylistically, I like to write helper functions for any API call that really give us the meat of what we care about to make our code more readable. So I'm going to create one function that looks up a profile or looks up a list of IDs, list of profiles, and just extracts the IDs out of it. Next, the lookup of user. Since this was a batch request, my helper just extracts the first one from the batch. Get follower count. We'll look up a whole profile and just extract the follower IDs. So now with these, the rest of my code will be a lot easier to read, and each of these functions are easy to look at independently. And finally, since I believe in testing, I'm going to make my batch size and export. This means when I'm writing a unit test, I can change the value of the batch size, and I don't have to create mock data of over 100 users just to test that my batch chunking works. So let's get started with the HTTP function. Here's how you write an HTTP function in Firebase. Function.https.onRequest. Now we have the ability to handle a raw request and response express object. And because we use the async keyword, we can use await inside this function. Which means I can have my error handling with just a try-catch block. If any error happens, log it so I can check out the production logs later, and do a 504. Now we're going to start with the username from the query parameter, and I've written a small helper to authenticate the Twitter API. So now let's go through our workflow. First, I get my profile. Now I find the IDs of my friends, break them into batches, and now I'm going to map each batch into a promise to fetch the results for that batch. So map, then to get follower count. So now we have an array of promises of results. Let's await to get the results. Now we can combine them with that flat map. And we can calculate our statistics. So now I have my friend count, my fame, so how many people follow me, the probability distribution, the number of friends who are more famous than I am, and the ratio. So if more than 0.5, or if this ratio is higher than 0.5, more than 50% of my friends are more famous than me. So let's log that just to make sure we have some interesting stats when we look at our production logs. We'll save it to the database. Oops. And since this is an HTTP function, we need to return something. We'll return a shorter version of that. So now we hand out the username and how many or what percentage of their friends are more famous than they are. So that's our HTTP function. But you'll notice I wrote this information to the database. And the reason why is it's not fun to just count how popular I am, but how well I fit in with the rest of the world. So I'm going to write a database function that listens to this node here. And it will use that to update some aggregate statistics. So this is what a database function looks like. Functions.database.ref. I write a pattern to match all the documents that I want to match. And then the event type on create. Whenever a new user adds their information, we'll update the aggregate statistics. So, as I said before, I am more famous than my friends if fewer than half of my friends are more famous than me. Makes sense? Now, because many users are going to try to update the same node, we'll use a transaction. Oops. And then we'll make sure we initialize our variable in case this is the first time that that transaction is run. We'll either update the more famous than peers count or the less famous than peers count. Always update the total and always calculate the new ratio. And just to make things mildly more interesting, we will log what the new stats are. So now we have our completed HTTP and database function. And we're going to hand it back to Lauren to show you how you can actually test this even outside of production.
Great, thank you, Thomas. Awesome, so Thomas just walked us through some tools and tips and tricks for how you can be writing your functions. Next, I want to talk about how you can test and debug these functions. So there are two main parts of testing. The first is writing unit tests. And we don't have enough time to dive into it today, but at the end, I'll give you some resources you can follow up on later. The second part of testing is tinkering with your code while you're still developing it. And this is what Thomas talked about earlier when he talked about playing with your code before production. So one tool that Firebase offers for this is a local server to emulate your HTTPS functions. So this looks at your project, sees if there are any functions that are listening to a request, and if there are, serve them up on local URLs. And you can go to a web browser to hit these URLs, use a curl command, or if you are doing a integration between hosting and function where hosting URLs are getting redirected to HTTPS functions, you can serve them both at the same time. And any interactions you have with the hosted site will also trigger your local functions. The cool thing about this is your local function will actually be talking to your production app and make real requests to external APIs like the Twitter API we're using today. How you use this is through the Firebase command line interface, the Firebase CLI. You run Firebase serve -- only functions if you're only serving up functions, or you add hosting if you're using both of them at the same time. So let's see this in action. And Thomas will actually help us out here. So we already ran the Firebase serve -- only hosting functions command on the terminal on the left. We see that we have a local website on the right, as well as a function at a URL that's printed here. So this is our aggregate statistics. Before this talk, we put in some Twitter handles of Firebasers. So you can see that there were 12 people that are less famous than their friends. So these 12 people have less followers than half of the people that they follow. And there were 4 people that were actually more famous than their friends. So these are more popular Firebasers among us, and they have more followers than half of the people that they follow. And you can see that 25% of the people are more famous than their friends. So we build this app by integrating hosting with functions. So Thomas right now is going to click on the Add Your Stat button. It's going to ask him to log into his Twitter account so we can pull up his statistics. Now when this login is done, the app is making a request to an internal URL, the /rating URL, which triggers our local function to run. And we can see logs here on the left. So everything after info is from the function. So we can see that the function was triggered, it started execution, we used authentication, that was the Twitter login. We printed the full stats. So that was the console log in our code. The console logs show up here. We see his Twitter handle is inlined. He has 869 followers, and he follows 438 people. And there are some more statistics, but the most interesting one is that 62% of the people that he follows have more followers than him. So Thomas is contributing to our less famous stat. You see on the right that went from 12 up to 13. And the line at the very bottom here in orange shows him that 62% of his friends are more famous than him. All right, let's switch back to the slides. So we were able to test out our HTTPS function, but if you remember, there were actually more functions in our directory. There was a database function. So how do we test that? We have another tool called the functions shell, which will emulate all of the functions in your project, no matter what trigger type they listen to. This is a full Node shell that is interactive that you can use regular JavaScript code with. How you use it is, again, through the Firebase CLI by running Firebase experimental functions shell. So let's see this in action. All right, so we already ran the command here, and it emulated two functions, the aggregate function as well as the rating function, which we already tested, so we won't test that again. And if you remember back to the code, the aggregate function is a database function that's looking at any new database writes to stats for a user that just used the app. So Thomas just used it. So let's actually, for test data, use the data that was just printed out from the previous function. So I'm going to copy this. So remember, this is an actual Node shell. So we can declare variables here. So we've got data right here. And in the shell, each of the functions that we emulated, the names of them actually becomes a function we can call. And calling that function invokes the local function. And the parameter we would put in is the test data. So we see that the function was successfully invoked, and the console logs from our functions are showing up here as well. So we are including his stats. We can double check here that, yep, our function pulled the right stat. Is he more famous than his friends? False, unfortunately. And because of that, we are updating our stats from 13 to 14 for the number of Firebasers less famous than their peers. And that brings us to the ratio of 22%. All right, let's jump back to the slides. So I'm sure you're all very anxious to see how unpopular you are. So you can pull out your phone, your computer. If you're on live stream, you can do this as well. Go to alone-together.firebaseapp.com. It's going to ask you to log in with your Twitter. So do that, and it'll pull your follower count, look at people that you follow, look at their follower count, and calculate statistics. All right, can we switch back to the demo computer, please? Wow, nobody's more famous yet. Come on. All right, so I see that as an audience, there are 11% of us that are more famous than our friends. All right, we can switch back to the slides. So you've just learned why Cloud Functions for Firebase is an excellent choice for writing server code. We talked about some tips for writing production quality functions, such as avoiding nested promises, using await async, and using TypeScript. We also learned about how you can be testing your functions locally through Firebase Serve and the functions shell. If you're interested in the source code of the app we just played with, you can find it at alone-together.firebaseapp.com/source. So I'll give you a second to take a photo of that. And if you want to learn even more, these are some resources to help you out. So I mentioned that testing is something that also involves unit testing, which we didn't dive into today. There is a talk that Thomas actually did at Google I/O earlier this year that you can find on YouTube titled Cloud Functions, Testability, and Open Source. You can go on our documentation page, firebase.google.com/docs/functions, and both of us will be at the Ask Firebase Lounge right after this talk to answer any additional questions you have. Thank you for listening. Here are our Twitter handles if you want to help us beat the friendship paradox. Thank you.